Hi, welcome to Science Chomp. Today we're going to be looking at making an image using a convex lens. Okay, so what we have here, we've got an optical axis, we've got a convex lens, we've got the focal points. Now, bear in mind this is not a mirror, it's a lens, so light can pass through in both directions, and as a result you've got focal points at both ends. You also got 2f, which is the center of curvature. That's always double the focal length. Bear in mind, I always measure from the center of the actual lens itself. So the focal length would be from the center right through to there, not necessarily at the surface. Just bear that in mind. Okay, so what exactly happens to light rays when we've got a convex lens? First of all, we need an object, and I'm going to draw an object over here. As usual, I'm going to draw an arrow. I'm going to color it in. There we are, this is my arrow. And the first thing that we can do is we need a big ruler. I mean, it's not going to cut it for my diagram, quite possibly. So I'm going to use this wooden ruler. It's a little bit longer. And I want to take a beam of light right from the top of this arrow through the center. And what happens is it goes straight through with no refraction at all. So I've just used this funny word, refraction. Refraction just means light that changes direction, okay? This one is not refracting, okay? It's gone straight through the middle like this, zero refraction. So again, refraction is when a light changes direction. This is what's going to happen to the other light rays. So I'm going to draw another light ray. This time it's going to go parallel to the optical axis. Try from here. Okay, so that's parallel to the optical axis. Put my ruler against it and I just slide it over like so. And I want to take this beam of light to the middle of the actual lens. And what happens is it goes through the focal point, which is down here. Like that. Give it an arrow here. So this changing of direction of the light is called refraction. Okay? We've got one more beam of light that we can do. And what we need to do is we need to take this beam of light and it goes straight through the focal point, which is over here. So if I'm accurate, let's have a look. If it goes through there to the center like so, and then what we've got to do is we've got to make it, once it leaves the lens, it goes parallel to the optical axis. Okay? Like so. Like so. Now, I haven't been massively good in my drawing. It's a little bit out, but if you do it really accurately, it all goes through the same point like so. And that forms your image like that. And then we've got to give it some image properties. Okay? So firstly, this one is upside down. We can call that inverted. Because it's made out of real light rays, we say it's a real image. Okay? And also, if you have a look at it, it's going to be a little bit smaller. So it's a inverted, real, smaller image. Okay? Now this is when the object is beyond 2f. Okay? And things change as you bring it closer in. So let's have a look at those. Okay, let's look at what happens now when you have an object which is between F and 2F. So I'm going to draw my object over here. And same thing as before, my first ray of light will go straight through the center of the lens with 0 refraction, so it does not change direction. Like this. Okay. My second ray of light, I am going to draw going parallel to the optical axis. Like this. I stop at the center of the lens itself, and it goes through the focal point. This kind of lens they call a converging lens because it converges the rays of light. Okay? And finally, if you wanted to, although it's not strictly necessary at this point, you could add a third ray of light. And of course, the more accurate you are with this, the better it's going to be. So it goes through here, stop at the center, and it goes parallel to the optical axis. So I'm going to have to use this again. So my optical axis is at that angle. I just moved. Hold it really steady. Kind of like this. That's where it's going to be. Like that. Okay, it's not perfectly perfect. It should all go basically through here. And this basically gives your image. So assume that if I drew it perfectly accurately, it all goes through the same point. Hope you get the idea. There we are. That's what it's meant to look like. Now, as you can see from this, this is considerably larger than this one. Okay, so if it's between F and 2F, the image is going to be, first of all, real, because it's made out of real light rays. It's going to be magnified, and it's going to be inverted. Inverted meaning upside down. Okay? Hopefully you can draw it a lot better than I can, but this is the idea. Let's have a look now what happens when we move it within the focal length itself, so just here. So within the focal length, my object is going to be over here, like so. And I'm going to do the same things as before. So first of all, my first ray of light is going to go through the center of the lens with 0 refraction. Like this, okay? My second ray of light, I am going to draw going parallel to the optical axis and then through the focal point. So here's the optical axis. You want to draw a parallel line here. To the center, and then through the focal point. Like this. Now, in order to make an image, what you've got to have is both the rays of light meeting, touching each other. Now they're not going to touch each other down here because the light is being converged, right? So it's actually going to happen in front of the lens over there. So what we've actually now got to do is we've actually got to extend these rays of light over on this side of the lens. Let's do that. Okay, so because now we're doing extrapolation, I'm going to make this a dotted line so that you know that these aren't actual real light rays here, they're virtual light rays. And I do the same with this blue ray of light. Okay, and where they meet, which is over here, that's where the top of the image forms. Okay, so like this. Okay, now as you can see, it is now a magnified image. So you can write magnified. Because it's made out of virtual light rays, it's going to be a virtual image, and it is going to be upright. Okay, we've got one more object to do, something which is going to be at F itself. So let's try that now. Okay, so we've got our convex lens. I'm going to draw an image directly on F, and let's see what happens to this. So the first ray of light I'm going to do is going to go straight through the middle of the lens with zero refraction. Goes straight through like that. The second ray of light I am going to do is going to go parallel to the optical axis. Like so. Center, and then like so. Now, as you can see, both of these rays of light are parallel, or at least they ought to be if you did it accurately enough. And parallel lines, they never meet. And as a result, if something is at the focal length of the convex lens, it will not produce any image at all. Thank you very much for watching. I'll see you in the next video. Goodbye.